Thank you for coming. This presentation is going to be about climate change and maple syrup production. It's certainly not everything that is known about maple trees and maple syrup production, so I'm not going to talk a lot about the changes in the distribution of sugar maple and red maple, but more about some of the things that we've learned, some of the uncertainties that still remain, and maybe some of the more odder things that people haven't spent a lot of time thinking about, but it seems like we tend to specialize in some of the odder things. So we'll go into that, and you will tell me later whether you think it's odd or not. But if you don't know me, I'm Dr. Tim Perkins. I'm from the University of Vermont Proctor Maple Research Center. We're out on the slope of Mount Mansfield, over on the other side, and we have about a 5,000 tap churning operation. Most of what we do is research, quite a variety of research. My particular specialty is in tree physiology, and so I dabble in climate change. I don't pretend to be a climatologist in any way. I just take what is the predominant view in the world of climate change science, and that climate is changing, and I'm not putting any sort of political or moral view on why this is happening, but it certainly is. I think the consensus among scientists, at least, is certainly that climate change is happening, and the real question, as far as the scientists are concerned, is how much climate is going to change and how much society can alter that change, whether we're going to allow it to continue to a very large extent, or it's going to be a fairly modest change. So that really is not what I'm going to talk about a great deal, but I'm going to focus more on just maple syrup production. And in starting, I want to acknowledge a couple of organizations. First of all, Tonewood with Dory Ross is a maple company that has been supporting climate change research at the University of Vermont for several years through regular donations that she has targeted towards climate change science, because it's just something that she's interested in, and so she makes some funding available for us. But most of this work is funded by the UVM College of Agriculture and Life Sciences, which is what we're part of through the Agricultural Experiment Station. And I want to acknowledge the collection of a lot of this data that I'm going to reference by the USDA National Ag Statistics Service. They've been very generous in sharing much of that data with us. So one of the first things I want to notice is that weather is quite variable. And so when we talk about weather and we talk about climate, it's really two different things. Weather is what is happening now and what might be forecast next week. Climate is what happens over the long term. And so what we're really looking at is long-term changes, not the fact that it snowed 2 weeks in April some year, but maybe the percentage of time that it snows in April or how much snow we got. So this is 1 year at the Proctor Center, and you kind of look outside the window and you don't see much except white. It seems like you're living inside an igloo at times. But then a year later, almost to the day from this, we had bare ground. So weather is quite variable. We can only really understand it by looking at it in the long term. So, I first wrote this a couple of years ago, so this might not be quite as recent and up to date, but when I did write this, 2015 through August 2016, up to that point, we'd had 16 months in a row where every month set a record for heat, according to the National Oceanographic and Atmospheric Administration. September 2016 just barely missed extending the record to a 17-month, but it was the second highest record for heat in September that we have. 2016 was on pace to break the records for the hottest year. Those same records had been broken in 2010, 2014, 2015, and then it did in fact break it in 2016. 2017 was really, really close, although We think 2017 had some really cold weather, but it also had some really hot weather. So 2017 wasn't a new record, but it was pretty close. So we're getting an awful lot of these, way more than would be expected just through natural variation. And at present, it's about 1.8 degrees warmer than it was a century ago, which doesn't seem like a lot when you think about how much temperature changes. But when you look at it over the average, 1.8 degrees is a tremendous amount. So what are some of the effects on maple syrup production? Well, there's been a fair amount written in scientific literature. Brian Shabbat, if anybody remembers, Dr. Shabbat was from the Cornell maple program. He worked at Cornell for many years, and he and a few collaborators wrote this paper, and they said that through the 21st century, warming temperatures, winter temperatures, are going to result in a decline in the number of sap flow days if traditional sap collection schedules are maintained. So what they were looking at is the historical period of time that people were actually making syrup. If we kept just making syrup during those times, then we were going to lose sap flow days. But as long as people adapted to that, then by modifying the time that they started collecting sap and started making syrup, there wasn't going to be any real net loss in sap flow days for most people over the region. And in the extreme north, so our friends up in Quebec might actually see an improvement in the number of sap flow days. Some other folks from Canada, Daniel Houle and his cooperators have done quite a bit of work on this, and their results indicated that in the southern part of Quebec, they were going to have short periods of maple syrup production due to unfavorable conditions in the spring. That were going to occur more frequently in the future if climate change continued along the path that's projected to happen. So the first one seemed to say as long as people adapted a bit, then it wasn't going to be terrible. This one is sort of saying, well, it's going to get worse and worse with climate change occurring in the future. And so there's a little bit of non-agreement, but there's been other studies as well. This is another one by Houle and Louise Deschênes, suggesting that climate change can favor maple syrup production in the north, which is what Shabbat also agreed, but that southern sections are going to be negatively affected. And they're mainly looking in Canada. So they agree. And other studies of, this is one that we did at the University of Vermont, looking at lots of different effects of projected climate change in northern Vermont, particularly focusing in on the Lake Champlain basis. A lot of different aspects of this study, but the portion that focused on maple said that the number of days that are suitable for maple syrup production are projected to decrease in the shift in annual cycles. So the time that we were going to make maple syrup each year in the future is going to shift towards an earlier time in the calendar year, and the number of days that were suitable for production is going to be reduced in the future. But if you look at it annually, the number of suitable days if we compare it to this base period in the 70s, is going to shrink from about 60 days down to 53. And then later, if we continue to project in the future, it's going to shorten even more down to about 49 days. So we're going to go from about 60 days that are suitable for maple production in the 70s down to about 49 in the mid to late century. So we're losing about 10, 11 days over maybe a 100-year time period. Here's another study, this one focusing mainly on Nova Scotia, and what they looked at is what has already happened. And their results indicated that maple syrup yield in Nova Scotia has fallen by nearly half because they were attributing this to effective growing degree days have increased. So what that means is it's gotten warmer, so crops can grow better, but for maple syrup production this isn't good. And they were saying, in fact, that their maple syrup production has been impacted due to warming temperatures. There's quite a bit of other work looking at Nova Scotia, New Brunswick that suggests there are other issues that might be going on that might also account for some of this, but anyway, this is what this group suggested is going on. Well, if you look at the Northeast temperature trends, this is a time series in just the Northeast in Vermont and just in the winter. So we can look at it over the entire year, but what we're mainly interested in is winter and late winter or early spring time period. And what you see from 1900 up to the early 2000s is that it's increased by about 2.8 degrees Fahrenheit over a little over 100 years. Over the entire year, it's increased by 1.8, but winter time is getting a lot warmer. You may not feel that way given the last month that we've had, but on average, over this long period of time, we have seen this change towards warmer and warmer during the winter period. So then a lot of people have sort of taken this and said, well, if you look at the production in Vermont from 1900 up to the 2000s, you see this really drastic drop off in maple syrup production. We were making a lot of syrup back in the early 1900s, and it just plummeted down to about the 1950s, and then it sort of leveled off. And a lot of people have grabbed onto that and said climate change destroyed the maple industry in Vermont, and the same sort of thing in the US. Climate change really destroyed maple production in the US. So is this really evidence for climate change? Well, probably not. There are a lot of things that have affected this and have resulted in this sort of drop off and a leveling. Mainly it's changing land use as the population, as the country has sort of shifted from a real rural agrarian farming society to much more industrial and much more suburban and urban society. People have really stopped working the land as much. They cut a lot of the forests. At this time, they still had a good amount of forests. They cut a lot of it in just prior to this and in this time period. And if you don't have the trees, you're not going to make a lot of syrup. So a lot of this was younger trees that are now quite mature, but they weren't at the time. Energy costs were very, very high, especially in the 1970s. Yields were very, very low. Technology still hadn't really kicked in a lot. We only had tubing starting, good tubing systems in maybe the 70s, and then vacuum systems in the 80s, and especially 90s and now, and then much, much better sanitation practices currently. So this sort of trend is really the conglomerate of a lot of different factors, not simply climate change. Climate change might be embedded in that to some degree, but the majority of the change is probably not climate related. And in fact, if you look at what's happened over the past few years, and this only goes up to a couple of years ago, this production has really gone up, and this past year is even higher than any of these numbers. So it certainly isn't simply climate change alone that has made this drop off, and if climate change were the predominant factor, then we saw early on that 2016, 2015, 2017 were some of the hottest years on record, but we're making quite a lot more syrup now. So it is a lot more complicated than sometimes what the press would kind of want to believe. And it makes a really nice, tidy story to say that climate change has really destroyed the maple industry and maple is going to disappear from the Northeast and be gone forever, and if they're lucky that Quebec will survive. But that doesn't really seem to be the story at all. So what sort of things do affect maple production? Well, what we focused on especially is looking at the things that affect the sap flow timing, something that we're all pretty familiar with. And there are a lot of different things that do affect sap flow timing and thus maple syrup production. One is collection technology. I just talked about gravity collection versus tubing, gravity versus vacuum. Size of sugaring operations has been getting larger and larger. Every census they do every 5 years, the Census of Agriculture includes maple. And they estimate the average size, and if you look at that, it's just been going up and up and up. So sugar makers who are making syrup are tapping more trees and making more syrup. The trend has been pretty consistent over the past 15 years. Well, if you have more and more trees, you can't wait until a day or two to start tapping them. You have to start tapping early. And some of these really large 10 to 50 to 100,000 tap operations start in January or even earlier. Not because, not entirely because of climate change, but largely because they need to tap early in order to finish at a time that's appropriate. Now, they are benefiting from the fact that we do seem to be getting some good January and February thaws in which you can make syrup, and so they do actually capture those, many of them, and can make some syrup during that time. Paraformaldehyde affected the timing to some degree, particularly when they banned it. A tap hole sanitizer, paraformaldehyde is a tap hole sanitizer, and it did extend the season, particularly towards the end. It turns out it's very harmful to tree health, and so it was banned and it is not used to any great extent these days, or hardly at all. We have good methods to detect paraformaldehyde, so it's really very, very low if used at all. The economics affect the timing of production quite a lot. What the expense of the production is versus what your net yield is, and so prices will affect how many people get out there and make syrup and when they actually do it. Various events are going to affect Sapflow timing. Insects and diseases can affect it, air pollution, acid rain, lots of things. So, but largely regional climate is one of the bigger drivers. How deep the snow is, how much precipitation we're getting, and really the biggest one is temperature. And then because we're scientists, we always like to throw things in that say other, which means we don't really know. There might be something else we can't explain, and so if we put other in there, then we can't be wrong. So other. The important variables that we're really interested in looking at are relating to climate change and how it affects Sapflow timing are the times in which people tap, the time in which they first start to boil, the last time they boil, and by subtracting season open from season close, we can get the duration. So those are what we'd really like to be able to look at over the long term to see how climate is affecting the timing of sap. So when we do that, we have to just sort of look at what the trends are. And so for season open and season close, is pretty much a relatively discrete beginning and ending of each season. Season starts when we start to get temperatures that are above freezing enough for there to be a sufficient amount of sap to boil. So that's what we call season open. Tapping, as I said, can be affected by a lot of things, particularly size of operation. But season beginning is really when do the majority of people they're tapped in and they collect enough sap to boil. So that's a pretty easy time to define for most producers. Season close, the same sort of thing. It's a fairly discrete time frame in that tap holes either dry out or you start making buddy syrup. And in either case, you're going to stop making syrup, and so that is our last boil, and that defines when the season actually closes for most people. Now, there are a little bit of changes that can drive that, but once we have those numbers, when the season opens, when the season closes, we end up with this season duration, which lasts for however many weeks there actually are, and we can start to look at those. Well, it's important, again, to go back and remind ourselves that the weather is variable, and so when we look at any one particular season, you see quite a lot of fluctuation from year to year. So this is something that Tim Wilmot put together after monitoring Sapflow for many years. So this is a time period from '99 to 2005, and And what you see, if you look at 1999, it had a little bit of sap here and a little here, and then a couple of weeks where we made no syrup at all. And then we got a couple, and then a little break, and then we made a lot of syrup for almost every day right to the end, and it stopped. This year was much more of a made syrup for a few days and cold, made syrup, cold, syrup, cold. We had maybe a good week here, and then a break, and then a few more good days. This year, cold, 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 made syrup every day, every day, every day, every day, every day, and then it ended. So every year is a little bit different, and we can only really start to understand this by looking at years over time, looking at the trends over many, many years. Well, one of the things we wanted to look at was historical records. We were able to get some, and this is one from central Vermont, and this is really hard to see. It's really hard to see in the original either, but this is a shingle that a maple producer in southern Vermont, their family had this farm and they made maple syrup, and this is starting, if you can read that, 1873. 1873, and they had many of these shingles, so this one goes from 1873 to 1879, and there's a little more data here, and they had just collected these over a period of time. When they filled up a shingle, they nailed it to the wall and left it there. And one year, they just decided to give it to us, and this just sort of came out of the blue, but they had recorded in here the time that they tapped and when they boiled. So if we looked at that, this is a tapping date from early 1870s up through mid-1930s. These open circles are the days that they tapped those years. A little bit of a break in the middle where they didn't do too much between like late 1880s and they had this one year in the early 1900s, but didn't make much syrup again until 1910. But still, all in the same place. Obviously, all using buckets. They didn't switch to tubing or vacuum back in the 1930s or anything. But so this is tapping date, and this is the trend line over that time. And what this shows is between mid-1870s up through the mid-1930s, they lost about 2.7 days, or they shifted the time frame in which they were actually tapping by about 2.7 days per decade. So if you look, when they first started, they were tapping in late March. By the time we get to 1930, they're tapping in early March. Now, maybe your tapping you can alter a little bit, but they tended not to back then too much because you don't want to hang buckets real early because they'd freeze and split. So people were pretty careful. You didn't have too many trees. It kind of depended on how many kids you had, how many trees you tapped. But they tended to tap within a fairly short period before they actually started to make syrup. Last boil, same kind of data, there's these closed circles. They were making syrup up until early May, and by the time in the 1870s, and by the time we get to the 1930s, they were usually done by sometime in early April. Climate change isn't new. Climate change has been going on for a long time. This is back in the industrial age. A lot of pollution going on back then too. Slightly different type, a lot of carbon emission, a lot of soot, but climate change was certainly happening back then. I don't think we can argue too much with these data. It was just a sugar maker collecting them in his own land. But that's the sort of trends we see from that sort of time period. There's not a lot of these data that are out there. If you happen to come across some or know of some, we'd certainly like to know about it. So the other sort of thing to look at in this data is, so they were tapping about 2.75 days earlier per decade, but their last boil was about 3.5 days earlier per decade. So those aren't exactly the same. Those two lines aren't going down equally fast. So the last boil was happening earlier and earlier compared to the tapping days. So the duration or the time frame that they were actually making syrup, they were losing about a day of sugaring every decade. Doesn't seem like a lot until you say, well, this was going from 1870 to 1930. So they lost, maybe close to a week of sugaring production during that time frame. So that takes us up to about 1930, when we started to have good records from NASS. And you could see syrup production dropping off and off and off. So maybe there's a little bit that actually is going on with climate change and the drop off in production, but we still can't attribute all of those changes to simply climate. We wanted to try to bring this more up to date in the 1930s, so we started this producer survey, and there have been a bunch of surveys that have been done. We were one of the first ones to do this, and so we found several records that were greater than 20 years from producers throughout the Northeast region who didn't change their methods of collection very much. They didn't change the size of their operations very much over that time period, and we wanted to look at that. So we did the survey in 2003 when we first started doing some climate change research. We started out with 200 producers who actually responded, but only 13 of those had long-term records and hadn't changed their production practices much during that time. 9 of them were tubing operations, 4 were bucket operations. They averaged about 3,000 taps, and they were from New York, Vermont, New Hampshire, and Quebec. The total time span that we had data for was about 44 years. So blue dots are tapping dates, and the blue line is the trend line. Season open are the green. This is when they first boiled, so it's pretty close between the tapping and then when they first started to boil. And this is season ending. So this goes from 1960 up through about 2003. And you can see again that this line is going down, but this line is going down even faster. So over that time frame from 1960 to 2003, we'd lost about 9 days on average of season open, or it had shifted 9 days earlier in the calendar year. Season close had shifted by about 10.9 days, and so the duration over that time frame, so the subtraction of this date from this date, we'd lost about 2 days, or about 0.43 decades. So, you know, approaching half a decade. The other data set said one day per decade. So, you know, that's kind of ballpark and very consistent that they're all still showing this trend towards shifting to an earlier and earlier time frame in the calendar year and loss of duration of that time. Well, you obviously can't have a loss of duration that continues forever because you're going to end up with no time at all. This goes up to 2003. So 2003, after 2003, there started to be some interesting developments. But about that time, we also started working with NASS to try to get some idea about it. And I would happen to be talking to the former director of NASS, and they started publishing in the NASS reports average season start days, average season end days. And I said, boy, that's really good that you have that. This was in the early 2000s. It's really great that you had that, but I wish we had it for 20 years ago. And he said, yeah, we do. We just haven't published it. So I said, well, send me the data, and they did. So it turns out throughout New England, NASS have been collecting the data since 1963. New York had been collecting it since 1972 and never really said much about it. And for this is quite a large number of producers, more than our 13. So we were able to get what we consider to be very, very good data for each individual state. So this is Massachusetts. For all of these graphs, this is the day of year. So you know, this is about March 1st, April 1st, May 1st. The open circles are the beginning of the season, season open. Closed circles are the season close. So this goes from 1963 to early 2000, so about 2010 maybe. And you can see this is season open. We're shifting to an earlier time frame in the year. Season close, shifting to an earlier time frame in the year. But in this case, it's shifted so much that the duration they lost in Massachusetts about 8.4 days over the time frame from 1963 to 2010. So they lost over a week of sugaring season in that time frame. We look at New York, they didn't start till 1972, but same sort of patterns, not quite as bad as Massachusetts. They lost 6.6 days. If we look at New Hampshire, you can see this line is going down really pretty fast, but this line is also going down pretty fast. So they haven't lost nearly as much. Only about 4.6 days of duration were lost over that time frame. This is Vermont. Same basic pattern as New Hampshire. We're shifting to an earlier time frame for both season open and season close. And I think this is probably 2012. And so we lost over that time frame about 3.3 days of our season. So there's a bit of a range, and the range depends on where you are. This is Maine, so they're shifting. Their line's not going down very fast though. And the season close is also shifting, and it's not going down very fast. One thing about the data from Maine is they were only doing southern Maine early on, and now they're doing the entire state, but the data seem to be pretty similar. So overall, they've only lost a little over 2 days of duration over the same time frame where Massachusetts lost 8 days. So why so much difference between the two? It turns out that if you look at all of them together, you get this sort of a conglomeration where on average lost about 1.1 day per decade, but it does range a little bit depending where you are. And if you look really close at where you are, I'm not going to make you look at all these numbers, but if you look at it based on latitude, so this is Massachusetts and this is Maine, as you go northward, taking the geographic center of the state, and you compare it to the season duration change over each decade, Massachusetts, because it's way in the south, is experiencing more warming, more loss of duration compared to places that are north. As you go north, New York is next in line geographically, and they've lost an intermediate amount. By the time you get up to Vermont, we've lost somewhere right in this range, along with New Hampshire, which makes a lot of sense because New Hampshire and Vermont are right side by side. So we're very, very similar in that respect. And then Maine, being the most north, hasn't lost nearly as much duration. So the further you go north, the less affected you are by climate change so far. Okay, any questions up to that point? Because I'm going to shift a little bit. Okay, so why haven't there been any changes or impacts on production if we're seeing this loss in duration that's been going on for a really, really long time, and our season is getting shorter and shorter and shorter? Why aren't we making less syrup like many people would think? Well, it's because we've had major improvements over the past couple of decades in sap collection technology. So tubing and fittings have improved, tubing system design operation, improved vacuum, and especially over the past 10 years, spout tubing and sanitation practices has improved. So when you start talking about sap tubing sanitation, what does that do? It does two things for maple producers. The first that most people sort of think about intuitively is that it extends the season a little bit at the far end. So you can have viable taps that keep running, don't dry out at the end of the season. So you're making syrup a little bit later than you would have maybe 20 years ago. But you're also tapping earlier because you have good sanitation practices. Those tap holes aren't drying out. So people say, if they're not drying out, I can tap earlier. I have a bigger operation, so I need to start tapping earlier. And because I'm tapping earlier, I'm collecting some of those sporadic runs that happen that I might not have captured 20, 30 years ago if I was using tubing and buckets. So we're actually, rather than the duration still continuing to go down and down, just over the past 10 years, due to vacuum, but especially due to tubing sanitation, we've actually reversed that, where now the duration is going back up again. So we're having a longer season than we used to have. And if you look back at the NASS records, the average start time is earlier, the average end time is later. So that duration and all these trends that we've seen since the 1870s have largely been negated up to this point. Technology can only help you so far, so at this point, unless something else comes out there that can affect these, then it's going to start going down again. But at least for a period of time, we've managed to reverse the trend and have it go towards a longer duration season. Will it go back down again? Over the very, very long term, yes, it will. But for now, at least, it isn't. The other thing that has increased it, at least up until the last couple of years, there have been pretty favorable economics. There have been quite high prices for bulk syrup. It's been amazing how much has changed in just the last few years. A few years ago, producers here in the US were very, very happy about prices. Now they're not. But the favorable economics and prices really drove also people tapping earlier and holding in there later. So what sort of short-term adaptations have people used and can you use? Well, one is to go with very, very much the improved spout and drop line sanitation practices that help you keep your tap holes viable for a longer period of time and help boost your yields. By doing that, you're reducing microbial contamination of the tap holes and reduce tap hole drying, which really isn't a drying process at all. It's a wound response process in the tree that results in drying out of tap holes, but it's more of a microbial response process. So it doesn't really affect season open that much, except for those sporadic days that you catch early on in the season, which are becoming a little bit more common, but it delays season close to a large degree and overall will increase syrup yield. So here's the part that's where it becomes even more odd. So if we look at the sugaring season and we look at all the records for when we normally have good production, and we're going to use the 1970 time frame, 1970 to 1999 time frame as sort of the baseline production. So if we look at the number of days where we have good projected sap flow, and we all know that sap flow is going to vary quite a bit depending upon the temperature that started and how cold it was and how windy it is and how sunny it is. But if we just say, what days are potentially good sap flow days according to the long-term climate records. So this is January, February, March, April, May. And during the period of 1970, 1999, we get a graph that looks like this. You had a few days in January, so we've always had January thaws. We get a few more days in February, but March and April were the really peak production times. And that's when people make maple syrup, when you get really good days for sap flows, temperatures well above freezing, temperatures at night down slightly below freezing. And those during the 1970, 1999 time frame were in mostly, like late February through early April. And there were a certain number of days associated with that. That's the duration. So if we start looking a little bit further ahead, this is a 2000 to 2010 spring season. What we get is, I don't know why this isn't quite lined up, but what we get is this time frame that's shifted a little bit, where we've added a few more days early on because we have better sanitation and because it's a little warmer. And we've added a little bit more days at the end because of better sanitation. So here we're tapping earlier, getting a few good days. We're able to do that because of sanitation, good sanitation practices. Good sanitation practices add a little bit more. So we've made this window of time a little bit broader, just a little bit. What were really two very distinct peaks start getting closer together. This is for Vermont. You could do this for lots of different places, but this is for northern Vermont. And when you look at this, the peak time periods for production get closer together. There's still a gap in between here, where you might get a little sporadic run here and there, but the peak periods are still separated and they're still too far apart to tap here and expect you're going to get a tap hole running then. Keep going in the future. They get even closer together. So here's your peak production period. Here's your peak production period in the spring. And you keep running this out. We don't really know how fast climate change is going to happen, but rather than end up with two separate seasons that you can't really span, they get closer and closer together, and eventually they come together. And you end up with one pretty long season that, you know, maybe mid-2100s, we could actually span a season from sometime in mid-November through mid-February. So that really is the question that we are interested in now, is really how long can we keep a tap hole open? Or are there things we can do to maintain tap hole viability from a time period in the fall through a time period in the spring? And it isn't because we're trying to increase production over that time, although that might happen, but it's really more to say what is possible later on in the future. And we're not the only ones to ask this question. We get asked this question all the time. The real answer is we really don't know. But at least theoretically, it's possible that we could end up with this one very long season, and the length of the duration of the season is going to be dependent upon how good the technology is that we can utilize that we have now or develop in the future to keep that tree running with good production of that time. Not asking the question yet of how good that is for the tree, or how good that is for the economics of syrup, or what it's going to do to supply. It's just more of a, this is kind of an oddball thing that could happen in the future. That's a very, very different scenario from the real gloom and doom of maple syrup production is going to disappear. We really have to think more broadly than that, than simply saying, oh, it's all going to disappear, so we can't do anything about it. So the question is, can we come up with ways to keep that season open for a longer time period? Perhaps not now, but perhaps for something that might happen in the future. So I know that probably sounds a little bit odd, but throughout New York, the conclusions we have is that throughout New York and New England, maple sugaring season is starting earlier and it's ending earlier than it historically did, at least up until the time people started really adopting good sanitation practices. After that point, things all really started to change. But season close, the last time we boiled, really is seeming to be affected a lot more than season open. Why is that happening? It's happening because the transition from winter to spring is happening faster. Winter isn't quite as cold, spring is hotter than it used to be, so we're going from winter to summer faster than we used to. The result of that is a loss of spring season. So the duration of the sugaring season, at least up until the time that we started using improved sanitation, was being reduced by about half to 1 day per decade, and it's about 16% overall shorter than it was 50 years ago, but again, up until we started using good sanitation. So the length of the season is really related to maple syrup yields if the sap collection technology is constant, but because we've had better ways of extracting sap, and because the sap duration season is decreasing, average per tap production could decrease, again, unless we change technology. So far, sap collection technology has really offset or even reversed to some extent the losses in yield that people might have expected. And we really don't know what's going to happen in the future. The scenarios range from very, very bleak to actually maybe quite good, depending upon the particular climate models you use and whether you think this very long season might be something that is. So this is just another maple producer survey which was started last fall by a company in Quebec that we worked with, SUNY ESF, Proctor Center and UVM Extension, along with the Federation syrup producers, to look at more about how climate has been changing. This is all done, so don't bother going to take this survey at this point, but the report has come out now in Quebec, and the English version should be out hopefully sometime this year. So lots of things to think about, lots of things that might change. We really haven't touched at all upon how maple tree distribution might change over time. There's a lot of scenarios that look at how maple tree distribution will change over time. In general, maple trees will eventually move northward, but most of the models that are done assume that the maple trees are going to re-equilibrate very, very fast. That's probably not a good assumption to make, because maple trees live for hundreds of years. Whether or not you can make maple syrup from a tree that's here now, 200 years from now, we don't know. But that tree still is going to probably be here, and maybe it has a good chance of still living 200 years from now. Even if the climate isn't perfect for it, if it got here first and it's already living, another tree isn't going to come and knock it down and take its place. It's going to take time. It's going to take time for that tree to go through its full life cycle. And then the other thing that really affects it that a lot of these models don't incorporate is people. If you look at the state of Vermont as a great example, there are far more sugar maple trees here than would naturally ever be here, because people in Vermont like sugar maple trees, and they cut other things down, and they keep the sugar maple trees around to make maple syrup out of. Well, it's kind of hard to argue, with a chainsaw. So if another tree comes in here that you don't like, and you'd rather keep the maple, you cut those other trees down. That's essentially what's happened over the last few hundred years. And so even though the models say maple might move out of here, it really is going to depend on what people decide to do as much as what the natural patterns would do themselves. So hopefully that's given you a few things to think about. It's kind of very different in many ways, but I hope that gives you a little bit of hope that there might be maple trees and maple syrup here for a period of time. So thank you.